Testing, testing. Wait a minute. I don't seem to be hearing myself. Let me just check my audio first. Give me a while. Right. I can actually hear myself, so that's awesome. Okay, we'll start very soon. Alright, let me just wait for a while to get everything ready as well as wait for more people to come in first. Okay, now there's something I want to mention, right? Something not so important, which is that I haven't really tried this question fully, this paper fully yet. So some of these questions I'll be trying for the first time now. But in my mind, I felt that I could go through straight away, so I decided to just go through it right now. Okay, so let's begin now. So this is our SMO 2025 Junior Round 1, where we go through the solutions of each question. Firstly, thank you for joining the stream. Right, I understand that after this morning's competition, most of you are probably very tired already. You probably don't want to stare at this kind of math anymore. But then you cannot control. Inside your heart, you know that you desperately want to know your results for this particular SMO, right? Okay, so this is what I'm going to do. I'm going to tell you what you can get. And then roughly using that, you should be able to estimate whether you can get into round 2 or not. Okay, let's start going through the questions. First question number 1 here. In the diagram below, we have two congruent semicircles with the centers O and O prime, and then they're overlapping as shown. Find the area of the shaded region if the radius of each semicircle is equals to 2. So for this question, well, I think that this is not too difficult, especially since this feels almost like a kind of like a PSLE type question, right? So what we can do for this shaded region is, let me try to cut it up. So I'll cut it up like this, right? And I'll cut it up like this. So what we can do is that we know how to find the area of a sector. So that means the sector is this area A plus B over here. A plus B is exactly going to be 1 over 6 of a circle, right? And it's the same circle no matter whether we are looking at the first one or the second one. And then 1 over 6 of a circle will be equals to 1 over 6 times pi times 2 squared. This one will be equals to 2 over 3 of pi. But then we also need to find, okay, how much is A plus 2B? Because this is what the question is asking. Luckily, we know exactly what A is supposed to be. Because for an equilateral triangle with side length of S, there is a formula that says that the area of this triangle is equals to square root 3 over 4 times of S squared. Right. Those of you in my Sec 1 class, you probably have heard this multiple times over the past few weeks, me repeating the fact that the area of equilateral triangle is this. So with the side length of the equilateral triangle being 2, we know that in this case, the area of it is equals to square root 3 over 4 times 2 squared, which is just square root of 3. Okay. So with this being square root of 3, can we figure out the final answer? We should, because this is A, right? So we can figure out that, okay, if I have B, it should be the answer from the left minus away the answer from the right. It should be 2 over 3 pi minus square root of 3. Therefore, the shaded area that we have here will be equals to A plus 2B, that's square root of 3 plus 2 times of 2 over 3 pi minus square root 3. So the result is 4 over 3 pi minus square root 3. Okay, so I'm not gonna pause too much because of the fact that if you want to rewatch each question again, you can scroll back on the YouTube link once this recording is done, once this streaming is over. So let's take a look at this question number 2 right now. Question number 2 says, we have these 6 points A, B, C, M, and O on the real number line. M is the midpoint of the line segment AB, N is the midpoint of the line segment BC, and then O is the midpoint of the line segment AC. Which of the following is correct? Now for this question, some of them you can try to see visually, but some of them is not so obvious. For the ones that are not so obvious, what can we do? We can try to set up variables, right? Because variables allow us to write, for example, one length in terms of another length. So it's a little bit similar to coordinate geometry, right? On the number line where you can just set up, for example, A as 0, for example, C as 1. Because if A is if A and C are not 0 and 1, you can always scale the diagram left and right or bigger and smaller to make sure that this is true. And you can let B be X. Then we can calculate the values at each of M and N. Firstly, O will be half because it is the middle of AC. M is the middle of AB, so that's just X over 2. What about N? It is the middle of BC, so you can think of it as the average of X and 1. That will be equals to X plus 1 over 2. And now, you have each of the values here. So the question wants to compare Cn and Om. Let's try to do that. What is Om? Om's value is going to be half minus X over 2. What about Cn? Cn's value will be equals to 1 minus X plus 1 over 2. But if you calculate out what that is, out of 2, that's 2 over 2 minus away X plus 1. So this is actually 1 minus X over 2, right? That's the same guy as the first expression on the left. Both of these are exactly 1 minus X over 2. And in that case, okay, then we know, hey, Cn must be equals to Om in all cases. So the answer is option B. Question number 3 here. It's given that this equation has two distinct solutions, alpha and beta. Find the value when you round alpha and beta down. Okay, so this is the greatest integer function. Right? Sometimes people also write it like this, which says that you can taking a look at the greatest integer less than or equals to x. So here, they tell you this equation has two distinct solutions, alpha and beta. Find alpha and beta, add up together, round down. What's the trick for this question? Well, the trick for this question is that your x cannot be too big or too small. Because if your x is too big, then this is too big. If x is too small, then this is too small. So either way, well, we know that x cannot be too big or too small. More specifically, what you can do is that you can go and bound it within some values. For example, you know that this value here will be at most 5x minus 2 over 3. So one equation you can solve already is the equation 5x minus 2 over 3 is at least 7x minus 31 over 2. So if you multiply by 6, you can get 2 times of 5x minus 2 is at least 3 times of 7x minus 31. So that's 10x minus 4 is at least 21x minus away 93. So then we can get to 11x here. And then you have minus 4 plus 93, that's equals to 89. Okay? So we know that when we try the values of x, we don't have to try values beyond, for example, the value of 8. Now, we can also do the same thing on the other side. We also know that the one where you take the floor function, what happens? In general, when you try to round down the value of x, it will be at least x minus 1, right? Because when you round down, you're decreasing by something that is going to be not as much as 1, right? Isn't it? Okay, so in that case, we can think this thing here is at least 5x minus 2 over 3 minus 1. So we can set up a new equation. 7x minus 31 over 2 is at least 5x minus 2 over 3 minus 1. Same thing, multiply it by 6. You have 21x minus 93 here. You have 10x minus 4 here, and then a minus 6. So from there, we can see that let's move everything to one side. 11x is at least 93 minus 4 minus 6, that's 83, right? So x is at least 8 and 3, sorry, x is at least 7 and 6 over 11, right? So we have these two values here. So x is actually not a lot of values that you can work here, right? So what do you think could be the answer for this question? Now already you don't need to do any more calculations because you already know the answer if one of them is, if your x value is going to be less than equals to 8 point something and more than equals to 7 point something, then if you add up the two of them, it's going to be between 14 and 16, right? So the answer should be 15. But if you actually want to do the solving, you can. So how to do the solving? So you just try out values in which this thing here on the right hand side is an integer, right? For example, I'll first try maybe 7x is equals to, okay, since we know that x is around 8 and 7x minus 31 must be an even number, we can try x to be around maybe a value such that 7x is 55, right? So if you try x to be that, you can get some kind of value, right? You can try to check 7x equals to 53. You can try to check 7x equals to 57. You can try to check 7x equals to 51 and try to see how many of them works. Okay, I will not check it for you here because we already know the answer for this question. So let's just move on to question number 4. Question number 4. I don't know if any of my Sec 1 intro students, they are in this stream right now. Because for those of you who attended my Sec 1 intro class, you have seen this exact problem before. The exact values here, 7a over 15 minus 1 and a squared minus 8a over 15. This appeared in our Sec 1 lesson, in Sec 1 intro lesson. Okay, I don't know how many of you remember. But anyway, the idea for this question is that let's try to compare these two by subtracting them. If we do a squared minus 8a minus over 15, subtract away 7a over 15 minus 1, then this is going to be a squared minus a plus 1. And when you complete the square for this thing here, we know that this is going to be a minus half squared minus 1 over 4, then plus 1. So it is going to be a minus half squared plus 3 over 4. It is bigger than 0. So therefore, q minus p is bigger than 0, so q has to be bigger than p. The answer for this question is B. And then let's continue on. Question number 5, we have a fair dice with numbers 1, 2, 3, 4, 5, 6 on its 6 faces, respectively, and it is rolled twice to give you two different numbers. Actually, the two numbers can be the same as well, right? Now, in the first and second rows, the dice land on numbers A and B, respectively. What's the probability that this has two distinct real roots? For a quadratic equation, how to tell the number of real roots is to look at the discriminant. So for the quadratic ax squared plus bx plus c equals to 0, the discriminant is going to be usually b squared minus 4ac. But for this, because they changed the values around, the discriminant for this question will actually be a squared minus 4 times 1 times b. And for there to be two distinct real roots, we need to make sure that this is bigger than 0. Okay? So the question becomes, how many cases in which a squared minus 4b is bigger than 0? Let's draw a 2 by 2 grid where a is from 1 to 6 and then when b is from 1 to 6 as well, because we know that it could be any one of these outcomes, right? Okay, in the first case where A is equals to 1, notice that none of them work, unfortunately. So that's a bit unfortunate. None of these values work when A equals 1. When A equals 2, in fact, none of them work as well. Because when A equals 2 and B equals 1, you get 2 squared minus 4 times 1. That's exactly 0. That's not bigger than 0, right? And then next case here, when A equals to 3, you realize, hey, this thing works because 3 squared minus 4 is bigger than 0. 3 squared minus 8 is also bigger than 0. 4 squared minus 4 is bigger than 0. 4 squared minus 8 is bigger than 0. 4 squared minus 12 is bigger than 0. Then next, 5 squared is 25. 20 what? 5 minus 4 minus 8 minus 12 minus 16 minus 20 are all bigger than 0. And, oh, sorry, the last one as well. 25 minus 24 is also bigger than 0. I almost forgot about that. And finally, 36 minus 4, 8, 10, uh, wait, 36 minus away, 4, 8, 12, 16, 20, and 24 are also going to be bigger than 0. So the ones that work here are these cases. So by listing them out, we can see that exactly 17 of them are ticks. And the entire 6 by 6 is going to be 36 of them, isn't it? So the answer will be C, 17 over 36. Okay, with that, we finish our short answer questions. Sorry, I mean our MCQ questions. Let's move on to our short answer questions. Question number 6, find the number of integers n's that satisfy this inequality. We realize that, okay, I don't need to consider so many cases, even though I have absolute value here. The cases I would need to consider are the case where n is at least 1, the case where n is going to be less than 1, but bigger than or equals to 0, or rather, or bigger than or equals to negative half, right? Because this thing is 0 when n is negative half. And the last case when n is smaller than negative half, but bigger than whatever, right? There's nothing else to consider. Okay, in the case number 1, when n is at least 1, we have this is 8n plus 4 less than or equals to 5n minus 5 minus 2n. Is this possible? Answer, no, right? Because if you look at it, 3n has to be at least 8n plus 9. That's not possible when n is at least 1. Case 2, what happens between n is 1 and negative half? In case 2, we can see that 2n plus 1 will stay as positive. However, n minus 1 is negative, right? So the absolute value will change sign. It will become 5 times of 1 minus n. Then we have a minus 2n at the back. So if you move the integers around, we have 8n plus 4 again. This thing here is 5 minus 5n minus 2n. So we can get 15n is less than or equals to 1. Is there any n here that works? There is. N equals to 0, right? N equals to 0 works in this case, but not n equals to anything else. And finally, for the last case here, where n is less than negative half, how many works here? Well, in that case, the left-hand side is no longer 2n plus 1. It is negative 2n minus 1, because this will be positive now. And then here I have on the right-hand side, 5 times of 1 minus n minus 2n. So it is minus 8n minus 4, 5 minus 5n minus 2n here. When you move all the n to the right side, you can get n here. When you move all the n to the left side, you can get minus 9. So what does that mean? It means that as long as n is at least minus 9, this will be true. Right. So in this case, there's n going to be negative 9, negative 8, negative 7, dot, 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 until negative 1. So these are all the possibilities that work. Okay, so the final answer for this question is 0. Together with these cases here, there are a total of 10 of them. Okay, let's move on to question number 7. In the diagram below, we have a rectangle ABCD. E and F are the midpoints of the sides AB and BC respectively. If the area of this rectangle is 24 cm squared, we're going to find the area of the shaded region in cm squared. This is a very common area question. And in fact, this area question here, if we cut it up by AC, then the right hand side, the area, the shaded area is exactly going to be 1/3 of triangle ABC. This is because if I connect this point to the point B, then from the fact that E and F are both the midpoints, I can label this as 1 unit and 1 unit. I can label this as 1 part and 1 part. Now, it's not hard to see that 1 unit is equals to 1 part. And the way we can see that is because of the fact that this area here is going to be 1/4 of the area of the rectangle, which is the same as this area here, which is going to be 1/4 the area of the rectangle as well. So from there, we can see that, okay, 1 unit equals to 1 part. Now, once you realize that 1 unit equals to 1 part, then what you can do is to use the fact that the bottom two lengths are actually equal to each other. And the bottom two lengths being equal to each other tells you, okay, the two triangles on the left, your triangle ACE and the triangle on the right, triangle BCE, they are the same area. So in that case, both of them will be 3 units or 3 parts. So in other words, this thing here is just 2 units. So we have the area on the left, which is exactly 12 because it's half of the triangle, and the area on the right, which will be 1/3 of the triangle. So what I'm saying is that this part right here is 1/3 times 12, that's equals to 4. So the area of the shaded is equals to 16. Okay, question number 8 here. Question number 8. This is quite a common idea that happens in the SMO. And this idea is called completing the rectangle. Those of my students who are from my Sec 2 class, you should have heard of this. Right, I went through this idea roughly 6 or 7 weeks ago in my Sec 2 class. So the idea behind completing the rectangle is to do wishful thinking. On the left hand side, you have x times y. So let's think of them as being in two separate brackets. There's a minus 9x. So you think about putting the minus 9 times x here. There's a minus 9y. So think about the minus 9 and put here so that we have a minus 9 times y. But this creates a term that we don't want. It creates a term minus 9 times minus 9, which is 81. So to balance it out, we have to subtract out 81 on the left-hand side. And this is our equation. In other words, x minus 9 times y minus 9 is equals to 101. And 101 is a prime, which means that there's only one way I can factorize it into positive integers, which is 1 times 101. So in other words, one of the numbers is equals to 10, one of the numbers is equals to 110. So then x squared plus y squared is equals to 10 squared plus 110 squared. That's 100 and 12100. So the answer is 12200. Okay, question number 9. This question is very interesting because this is a very rare type of question to come out on the SMO. But they give you a word problem, but they also give you something that is actually a number theory in a word problem. So what do I mean by that? Let's see. In a fundraising campaign of a school, 11 girls and B boys of class 2A raised the same total amount as of class 2B, which is 9 boys and G girls. And the average amount raised by each of the two classes is $X. So that means that actually, if you look at it, 11 girls plus B boys of the first class times X is the same as 9 boys plus G girls of the second class times X. So these two are the same thing. We can remove them. So that means that 11 plus boy is 9 plus girl. Okay, that's very interesting. But now what they ask you to do is that the total amount that each class raised is going to be this value. And when you take a look at this value, you might notice a few things interesting about this value. You notice that there's a 9, there's an 11. So it seems like it's very related to the numbers I have at the start. Let's try to take out a 11 plus b here. Can we do that? Turns out we can. So this is a 11 plus b of g plus 9b plus 145. So if I'm dividing by the number of students, which is 11 plus b for, let's say, the first class, then this is the average amount raised by each class, which is x. But I also know that, hey, the first part of it is just g, right? So this is going to be g plus 9b plus 145 over 11 plus b. That's x. Now, here, how to continue? Well, notice that 9b plus 145, you can split it into 9b plus 99 plus another 46. And then that allows you to take out the value of 9. So it's g plus 9 plus 46 over b plus 11. Right? And then what that allows you to do is that it allows you to see that this thing here is equals to x, which means that b plus 11 is a factor of 46. So there are only two factors of 46 which are bigger than 11, right? So it's either going to be b plus 11 equals to 23 or b plus 11 equals to 46. Which one is it? If you try the very first one, b plus 11 equals 23, you have a trouble. Because if b plus 11 equals to 23, in the first case here, then g plus 9 being the same thing as b plus 11 will give you the fact that this is 23 plus 46 over 23 is equals to x. But in that case, x must be 25, which is a value that's less than 30. So this doesn't work. So it must be the second case, where b plus 11 equals to 46. And then in that case, this x here will just be equals to 46 plus 46 over 46, that's equals to 47, which is the final answer for this question. Okay, question number 10. Question number 10 for my Sec 1 and Sec 2 students. You should be very happy to see this question, right? Because you've seen this question many, many times before. You know what to do with it. Now, I would do the pen spinning thing if I could, but unfortunately, I don't really have the annotation ability to do that on screen. So let me go through the more standard method to do this question, which is to use the butterfly angle fact, which is the fact that if you have two angles on the left, A and B, then actually A plus B is equals to X plus Y, where the angles X and Y are the two angles on the right. What that allows you to do is that it allows you to bring angle A and angle G over here. Now, together with the rest of angles F, E, D, C, and B, what we have done to this diagram is that we have transported it into this figure, which is actually a pentagon. And if you have a pentagon, then the sum of angles is 540 degrees. So therefore, x is 540. Okay. Although I'm unable to show you the pen spinning idea, but those of you who know what I'm talking about, you can try to draw that on your screen as well and see that you managed to get it done. Okay. Okay, I do see some kind of comment on the stream, but let me try to find a way to see it first. I need to close some windows to be able to see it. Give me a while. Okay, someone is just saying hi. Okay, welcome, welcome. Hi, hi, hi. Yes. Yeah, let's continue on. Question number 11. Okay, wait. Somehow I cannot see the new messages well. Oh, yeah, another height. Yes, awesome. Good. Okay, so question number 11. Let n be a positive integer. If the sum of the digits of this guy 10 to the power of 2n minus, oops, typo here, 10 to the power n minus 5 is equals to 4225, find the value of n. So what's this? Well, there's going to be, let me illustrate for n equals to 6, right? For example, no, sorry, not n equals 6, n equals to 3. Because n equals 3, the first number is what? Is it? It is what everyone wants to be in Singapore. You want to be a millionaire, right? So this is equals to 1 million, when n equals 3. But unfortunately, some guy has to take away 1,000 from you, and then some guy has to take away 5 from you. So the result that you're left with will be equals to what? The result you're left with is 998,995, right? After you remove 1,005. So now that you have a good idea what kind of number this is, you can continue on. If you imagine that you have 10 to the power of 2n minus 10 to the power of n minus 5, then what you can get is you're going to have 2n digits, out of which a bunch of them will be 9, exactly n minus 1 of it. Then you follow up with a 8, followed by another bunch of 9s, exactly n minus 1 again, and then you have a 5 at the back. So we know how to add this up. Right, if we add this up, there will be 13 from the 8 plus the 5, and also 9 times of, actually 18 times of n minus 1, right? Because there are two groups of the 9s. Okay, so we know that this thing here is equals to our value 4225. If we subtract out 13, you can get 4212. So now, here, is there any way to divide by 18 quickly? Well, usually no. Usually I want to simplify first. I notice that they are all multiples of 6, right? Simplify. So we can get 3 times of n minus 1 equals to 704. And then here dividing by 3 is a bit easier. So n minus 1 will be equals to 268, I think. So n is 269. Okay, and that's the answer. For our next question, number 12. The number of sides of two regular polygons differ by 25. Right, so if one of them is an n-sided polygon, then the other one you can say is n plus 25-sided polygon. Now they give you the two interior angles of these polygons, and then you'll have the difference be equals to 15 degrees. Find the sum of the number of sides of these two polygons. So what's the trick for this question? The question tells you interior angles, but it's a trick. You don't want to take a look at the interior angles. You want to take a look at the exterior angles because of the following fact. The sum of exterior angles of a polygon is equals to how much? It is always 360 degrees, right? Regardless of how many sides you have. So if the question tells you that, okay, you have two interior angles, this guy and this guy that differ by 15 degrees, what can you say? You can say that, well, the exterior angles will also differ by 15 degrees, right? And that's much easier because we have 360 over n minus 360 over n plus 25 is equals to 15 degrees. Unfortunately, we still have to solve a quadratic here because I can first divide by 15. 360 divided by 15 is equals to 24. So 24, 1 over n minus 1 over n plus 25 is equals to 1. So if you calculate out what this is, 24, then the numerator here is 25 plus n minus n over n times n plus 25 is equals to 1. So then we can get that 24 times 25 over this thing here is equals to 1. Okay, so this is what we have. Now, some of you probably will be very tempted. Okay, tempted to do what? tempted to go and solve a quadratic equation, right? Maybe some of you really like to solve quadratic equations. Okay, if you like to do that, then of course I'm not going to stop you. But is there any better way to do this? Well, actually, you can do this using number theory, right? If you know that this is equals to 600, you can look for factors of 600 that differ by 25. Of course, 10 times 60, it doesn't quite work, but 20 times 30 is too close together, right? So what to do? You try something in between these 20 and 30. Sorry, 20 and 10, right? What is a good factor of 600? Well, if you decided to try 15, then you end up at the correct answer. So actually, we know that one of them will be 15, one of them will be 40. Okay, I see someone asking for question number 11 here. I'm going through a little bit faster because of the fact that you can rewind on your own. So if you find this, if you want to take a look at 11 more specifically, you can always backtrack, maybe 2 to 3 minutes, right? And look at it yourself. So anyway, the sum of the sides will be equals to 55. Okay, let's move on to the next question, number 13. Suppose m and n are positive integers. You think I made a mistake in calculation? Okay. Maybe we'll do this at the end, right? Maybe after I go through all 25 questions, if you are still here, I will try to come back to this question number 11 again. So suppose that m and n are positive integers such that this guy is a factor of 7 power m plus 7 power n. Find the smallest possible value of m plus n. So when you have these powers of 7, what you can do is that we can think about, okay, there's probably a multiple of 7. Let's look whether there's a 7 within this guy. So if we look at that, we can see, okay, if I try to divide by 7, there is. This is in fact 7 times 34. Yes, the answer is 468. Okay, then let me go through it after I finish question 13. So I'll go back to it after I finish this. So this is a 7 times 34, that's 238. Okay, very nice. So what do we know? We know that there will be a 7 from here, right? So if you take a look at 7 here, then it's going to be 7 power something else plus 7 power something else. And this guy must be a multiple of 34. Now, 7 and 34, they are co-prime. They don't share any common factors. So all the extra 7s, do you really care about it? Not really, right? So I can divide by as many 7s as I want here to end up at something that looks like 7 power k plus 1. And this has to be a multiple of 34. Okay, so in that case, when would this be possible? Now, one thing is that you can just try to bash out every single possibility, right? Because for this to be multiple of 34, what you just need to do is to try k equals 1, k equals 2, and so on, and hope that you can notice a pattern by some point. Right, so that's the idea we can do here. So let's try to do that. Mod 34. 7 is just going to be 7. 7 squared is 49. Mod 34 is equals to 15. Right. 7 cubed involves taking that 15, multiply by 7 one more time. That's 105. And 105 mod 34 is actually equals to 3. Right? Because of the fact that this uh, 34 times 3 is 102. Right? So then we have this 105 minus 102 is going to give you 3. Then let's multiply by another 7 again. That's going to give you 21. Multiply by another 7 again. That's going to give you 147. So this time, let's do some calculations. 34 times 4 is equals to, if you calculate out 136, right? 147 minus 136 is equals to 11. Okay, and then we can continue on the process. So eventually, the pattern will repeat itself. So 77 minus away 68, the value is equals to 9, right? Which actually you can also find by doing what? By squaring the value from 7 cubed, right? Because of the fact that 7 to the power 6 is equals to 7 cubed squared. And then we can go on until we hit the value that we want to hit. So the next value is 63. 63 is going to be what? Here, 63 minus 34 will be the value of, what's this? 29. Yeah. So far, there's no pattern that repeats itself, right? Not that I see any anyway. So here, I can use the fact that 29 is going to be congruent to what? It's congruent to 5. Negative 5, sorry, mod 34. So if I multiply it by one more time, I get something that's negative 35 mod 34, which is congruent to negative 1. And when I see that, I'm very happy. Because when I see negative 1, I know I can skip all the next few values. If 7 power 8 is congruent to negative 1, then 7 power 16 will be congruent to 1 mod 34. Okay, so this is a trick you can look for when you're doing your modular arithmetic, right? If you notice that a value here is going to be congruent to negative 1, then the square of it will be congruent to 1 mod whatever thing you're looking for. Okay, so if I know that this 16 works, let's come back to this question again. Wait, I just realized something. I made a mistake here. I don't want 7 power 16. I want 7 power 8 actually. Because 7 power 8 is the one that will satisfy the equation here. I noticed that 7 power 8 plus 1 is congruent to 0 mod 34. Okay, so with that, our best choice of A is 8. Our best choice of B is 0. So then, in that case, M should be 9 and N should be 1. The sum is equals to 10. Now, as promised, let me go back and review this question number 11, just for a short while, just to make sure that probably I made a mistake here that I can correct. So question number 11, this is 468. Let me see, where did I make a calculation error? Hmm, I don't see it though, unless I make some big enough mistake somewhere. I think you divided wrongly. Divide by 6. Hmm. Okay, let me check again from the start. So here what we have is yeah, 10 power 2n minus 10 power n minus 5. Yeah, the calculation is correct. And then we have 13 plus 18 times of n minus 1. Yeah, 4212 divided by 18 is going to give you 3 to the power n minus 1 is 702. Hmm? 3 times n minus 1 is 702. But in that case, oh yeah, 3 times. Okay, this is definitely wrong. Yeah, I divided wrongly here, definitely. So yeah, I divided by 6. Somehow I divided 12 by 3 and the end. So this is 702. Yes, you're right here. So this is not 268. But then even then, it doesn't make sense because if I try to divide this by 3, what do I get? 264, right? Or am I making a mistake somewhere? Okay. 702 divided by 3. Let me just try to work it out. Oh, it's 2 3 something. No wonder why. No wonder. 2 3 234. Oh, okay, okay. N is 234. N minus 1 is 234. Then you can get 235 here. Yeah, yeah, that's right, that's right, that's right. Sorry about it. Hmm. This is correct. Okay, so the answer is 235. Then the guy that says it should be 234. No, 233. Why got all these answers popping up? Some out of nowhere. Uh, um. So for the first part, let's say I do n equals to 3, right? You can agree that this is 3 digit, this is 3 digit, right? So if you have 10 to the power 2n, there should be n digit and n digit here, right? So that's where the n minus 1 comes from. Anyway, okay, let me continue with where we left off, which is where do you leave off? Yeah, we finished question number 13, right? The answer here is 10. Right. It's okay that you can correct me. It's fine, right? Because I some of these questions I'm just seeing for the first time. I can make some calculation mistakes. Okay, question number 14. Suppose that x is a positive real number such that this 27 power x is equals to 1 over x. And then here's a unique solution. Find the value of 2025 times x. Now, surprisingly, the idea for this question is to do what? Is to do guess and check. Right? It is to guess and check. Why? Because 27 over x is what we call increasing function. As x increases, this guy will become bigger and bigger. Meanwhile, 1 over x is what we call a decreasing function. As x is a positive value and then it decreases, as x increases, 1 over x will decrease. So what you want to just do is you want to find some medium intersection where the increasing guy intersects the decreasing guy at some point. Okay, so what to do here? Well, you can try some values. Don't try x equals 0, right? Because you don't want to divide by 0. Let's try x equals to 1. But even that, you can already realize that the 27 to power 1 is way too big. So you know that the answer will be some kind of number between 0 and 1. And then now the thing you want to try is, okay, 27 is a cube number. So should I take square root? No, that doesn't make sense, right? So let's try to take cube root. And in that case, if you take the cube root of 27, this is to power 1 over 3. You realize that this is 3, which is exactly 1 over 1 over 3. Right? So you figure out that x is 1 over 3 here. Therefore, the answer of 2025 times x is equals to 675. Yes. Okay, question number 15. This question here, even though it looks very scary, but actually it's not too scary. The trick is that every time you see something that's related to x, you want to replace it. What do I mean by that? Let's take a look at what we have on the right hand side. This value here, I noticed that this 3 plus square root of 2026 looks like x, right? In fact, it is exactly equals to what? It is exactly equals to x plus 1. So my first step is I will try to do x cubed minus x plus 1 of x squared. Okay, so that's equals to minus x squared. Okay, so now that I can minus x squared, now I try to carry out the next step. How to continue? Well, this guy here, does that look like x? Somewhat, but it's not as easy of expression, right? Because of the fact that there is a 2 in front, which makes it not so fun. So here, one idea is that you can try to express this in terms of x. Another idea that I'm seeing is that I can try to actually combine these two together and factorize out the x term from both of them. So I can get 1 plus 2 times of this square root minus away x. And this is pretty nice because if you take a look at what this is going to be, x, and this thing minus x will be equals to, if you look at it, just square root of 2026 minus 1, right? So now, if you take a look at what this is square root of 2026 plus 2, square root of 2026 minus 1. And finally, at this step, you want to bring in the last guy, which you left out all the way, minus square root of 2026 into the equation. Because here, when you do the expansion, the square roots will disappear. This guy is 2026. This guy is 2 times of it. This guy is minus 1 times of it. But remember, you have the part in red color at the back as well, where you subtract off a copy of it, right? And finally, you have a 2 times minus 1, so there's a minus 2 at the back. So the answer for this question will be equals to 2024. Now, of course, you could have also chosen to do the other way where you just set this in terms of x, but that will be roughly the same length of your solution as well. Okay, let's move on to question number 16. The 4-digit whole number ABCD is a perfect square, and then the 2-digit whole numbers PQ and RS are formed by adding 17 to A, B, and CD respectively. In other words, you start with ABCD, you add 1717, you get PQRS. But you know that both of these are perfect squares. In other words, you can write it as m squared plus 1717 is equals to n squared. So 1717 is equals to difference of squares, n minus n times n plus m. And they already tell you how to factorize it. Because 1717, it has to be 17 times 101. Now, of course, you can also try to do it where you have 1 times 1717, right? But that doesn't work because in this case, n will be a 4-digit number. And of course, a 4-digit number squared will not be equals to this PQRS. So then, we get that this guy must be 101. This guy must be equals to 17. So now it becomes a question of finding n. So n, if you add them up, 2n is 118. So n is equals to 59. So n squared is 59 squared. This is equals to the value of 3481, right? So then the other guy will be equals to 3481 minus 1717. So that's going to be 1764. This is a 42 squared, so this is correct. So therefore, once you have these two values here, their sum will be equals to 5245. That is the final answer. Question number 17. In the diagram below, we have a trapezium ABCD. AB is parallel to DC, and AB is equals to 10. P is the point where you have BP equals to 4 times of PC. So it's a ratio of 4 to 1. Then they tell you area of APD over area of APB is 15 over 4. Find the length of DC in cm. Okay, so this is the question we have over here. Now, how do you interpret the area ratio being this 15 over 4? Now, what I'll do here is that I'll actually try to split up the diagram. Right. What I mean by split up the diagram here, it means that I'll try to cut a horizontal line through here. Okay. Now, what it allows us to do is that it allows us to find the things in terms of the ratios. So for example, since the ratio on the outside is 4 to 1, what we can do is that we can set this as, let's say, 10 plus 5x. Then this thing here must be 10 plus 4x. Okay, because the thing that you add, it will be in the ratio of 4 to 5. because this side is 4 to 5. So in some sense, you can think of it as similar trapeziums, although I don't really like to use that term because um, it's not very nice. So another way you can think about this is that you can actually extend this thing here and then use similar triangles, right? Which is probably a better idea. Anyway, I know that the sides are 10 plus 4x and 10 plus 5x. How to continue? Well, I also know that the height is in the ratio of 4 to 1. So let me label this as 4 units and 1 units, and then I can write each of the areas in terms of our unknowns. So what's the area of APB, the smaller one? The area of APB will be equals to, if you calculate this, that's equals to half times base times height. The height is 4 units, so the base is 10 units. This is equals to 20 units area. Okay, let me use black color. Then we can also go and calculate the area of this part over here. Now notice that this part over here is split into two triangles basically. One of them uses the top triangle with the height being 4 unit, the base being 10 plus 4x. The bottom triangle, same thing. The height is 1 unit, the base is equals to 10 plus 4x. So the area of this part here is going to be half times 10 plus 4x times the height of 5 units. So this is what we have. So this thing here will be equals to 2.5 units times 10 plus 4x. So that's going to be 25 units plus 10 units times x. Looks very weird, right? Because of the double variable. But now you can compare. If you know the area is 15 to 4, then you know that this guy in red color to this term in black color will be equals to 15 to 4. So we can do cross multiplication. 15 times of 20 units is equals to 4 times of 25 units plus 10 units times x. Now here, there's units on both sides, so let's just get rid of these units. It's not important. Then what we have is 300 is equals to 100 plus 40x. So then x must be 5. Okay, after we find x is 5, we're done because we know that DC itself will be equals to 10 plus 5x, that's equals to 35. That's the answer for this question. Okay, question number 18. If x cubed plus 4x is equals to 8, find the value of x power 7 plus 64x squared. This is a standard example of something called reduction of powers. Because we don't want to actually solve the cubic equation. If we solve the cubic equation, then there's no point. It will take you too much time to do it. And then later on, you need to substitute back inside the second expression, which is not good. Reduction of power says x cubed is 8 minus 4x. So I'm going to take this guy, I'm going to put inside here. X power 7 is what? Is x times x cubed, isn't it? So that's going to be x, 8 minus 4x, 8 minus 4x. To make our job a little bit easier, let's take out the 16. So you have 16 of x. Then 2 minus x and 2 minus x multiplied together will give you what? That's x squared minus 4x plus 4. So actually that's going to be what? That's going to be 16x cubed minus 64x squared. And when you see this, you're very happy, right? Because you know that there's a plus 64x squared later on. Then plus a 64x. So now you can bring in this guy. Okay, say that I'm going to put it here, and then I can cancel out the x squared term. So it's just going to be 16x cubed plus 64x. Now here, do you need to do reduction of powers again? No need, because you can just see that it's 16x cubed plus 4x. That's 16 times 8. Finish. Question number 19. In how many ways can 4 boys and 3 girls stand in a line such that every boy is adjacent to at least one girl? For this way, for this question, I mean, you actually want to write out all the possibilities. Because firstly, if you're arranging 4 boys and 3 girls, assuming that the boys and the girls are identical, there's only going to be 7 choose 3, 35 ways at most. So there's not many cases where every boy is adjacent to at least one girl. It is small enough that you can even just try to write it out yourself. Now, but here we're going to do something to make the 35 cases even easier to consider. I'm going to use the idea of symmetry. So the idea of symmetry says that if you have 3 girls, then there's always going to be one of this side or this side that has at least 2 girls, right? So let's just say that maybe the first side has at least 2 girls, okay? And then later I'll discuss the case where the other side has at least 2 girls and whether there's any overlap. So in this first case, this side has at least 2 girls. Can it be all 3 girls on this side? No, because like that B, 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 they're all next to each other, right? That's not possible. So then we know that there's exactly 2 girls here. Okay, so let's discuss. If it's B and B, is it possible? The answer is no, because the last B, sorry, no, girls, I mean. G and G, is this possible? No, because this is the last girl. But then in this case, the middle one does not have girl next to it. Next, G and G, then there's only one position left here, which is this position. Or if it's G and G, there's only one position left here, which is this position. So then these are the cases where you have girl in the first, second, or third position. Now the rest of the cases will involve a girl in the fourth position, which you need to be a bit careful about, because these are the cases which can be symmetric. You know the first two cases are definitely uh, not symmetric. Huh? So if you have G and G, where can the last girl be? It can be here, or it can be all the way at the side. Okay. So now you can look at the next case here when it is G and let's say G. Then where can the last girl be? Again, same situation, right? The girl can be here, the girl can be here. So these are the 4 cases where there's a girl in the middle. Then these 2 cases here need to times 2 because these 2 cases have their own symmetric cases. But the bottom 4 cases, you don't need to times 2 because you already list out all the cases where there's a girl in the middle, right? So in total, you can see that there are exactly 8 cases where every boy is adjacent to at least one girl. If you have these 8 cases here, then what can you do with them? You can just multiply 8 by the number of ways to arrange the boys and the girls. So actually, the 4 boys, there are 4 factorial ways to arrange them. 3 girls, there are 3 factorial ways to arrange them. So this is equals to 1152. Wait, let me just calculate first. Is this 1152? It is, right? Okay. I think that's the answer. Okay. Next question. We have our question number 20. Okay, question number 20. For those of you who are in my Set 1 class, right, if you see this question, you should be very happy because we just did something like this 3 weeks ago. But instead of that question, I think this area was 2007 or something like that. Anyway, so in the diagram, we have a trapezium ABCD. AB is parallel to BC, and the angle bisector of angles BCD is perpendicular. Whenever you see angle bisector and perpendicular together in the same question, you must be alert because this indicates possibly congruent triangles. It intersects AD at a point E where D is equals to 2AE. And then if the triangle CED is 16, find the area of the triangle ABCD. Well, the trick for this question is to get the congruent triangles by extending AE and BC. Now, the congruent triangles, I know they don't really look like congruent triangles, but they are because of the fact that they share a common angle at C, they share the 90 degrees angle, and the side that they share is the same. So they are actually congruent, which means that on the left-hand side is actually a 2 to 1 to 1. because we know that this length here must be the same length as this one here. So what that actually means is that the uh, area of 16, you can also bring it here, area of 16. So the entire trapezium's area is 32 if you include the, if you, okay, sorry, it's 32 minus away the top triangle, right? So the question becomes, how much is the top triangle? Well, here you can use similarity. You know that the side ratio is going to be 1 to 4. So the area ratio is going to be 1 to 16. So therefore, the area of this part at the top will be exactly 1 over 16 of 32, which is 2. So the final answer is 32 minus 2, 30. Question number 21. We have a set of 6 whole numbers, exactly 3 of which are prime. And they're not necessarily distinct. There's a median of, there's a mean of 16, a median of 16.5, and a unique mode of 17. So we usually start with the unique mode first. Unique mode means that the most common number is unique. So the most common number will occur at least twice. And if the median is 16.5, then 17, you can write them both on the same side. And that tells you that on the other side of the median, it must be 16. Because when you have 6 numbers, the median is the average of the middle two. So this is what we have. Now you also have a range of 14, so you know that this gap here is going to be a difference of 14. So then now what you can do is that you can try to see what is possible for the remaining 3 numbers. You know that for the 3 numbers A, B, and C, the mean is 16 means what? It means that A plus B plus C is equals to 46. Right? Because if you go and calculate out, the entire thing is 6 times 16, then minus of 16, minus of 17, minus 17, you can get 46 here. So, and you know that, in fact, A minus C equals to 14. So here, what you can do is that you can just try to list them out to see how many of them work. For example, I'll actually start listing out in this order, C, A, and B. C could be 1. In that case, A could be 15. Actually, no, it cannot be, right? Because A must be at least 17. So let's start from C equals to 3. A is 17 here. Then what's B? That's 46 minus 20, that's equals to 26. That's not possible, right? B must be lower than 16. If B is lower than 16, you can immediately move on and try 8 and 22 because you want to decrease B by 10. So if we try 8 and 22, yes, B will decrease by 10, B will go to 16. But even then, it doesn't work, right? Because B cannot be exactly 16. So let's do it one more time. 9, 23, 15. Is this acceptable? Then you realize that, yeah, this is acceptable because 23, 17, and 17, um, they are all prime numbers. So you already have the answer, but let's just do a quick check that nothing else works. For example, 10, 24, and 13. Wait a minute. No, that's, wait, sorry. 9, 23, and 14, sorry. Sorry about that. But it's correct though. Yeah. Then the next one is 10, 24, and 12, right? It's not, doesn't have any primes. Then if you try 11, 25, and 10, then in this case, C is bigger than B already. So you know it's impossible. So therefore, you know the only case is for the case of 9, 23, and 14. Okay, the sum of squares of all 6 numbers will be 23 squared plus 17 squared plus 17 squared plus 16 squared plus 14 squared plus 9 squared. Yeah, this is nothing special to calculate it. You just have to calculate everything out. So let me write the numbers on the left. 289 as well. Then this next one, 16 squared, 14 squared, and then 9 squared. Okay, add all of them up together. So what you have is 33, 30. Is a 0 at the back. Okay, that's very interesting. And then what we have is gonna be 4, and then here what you're going to have is going to be 16, right? So it should be 1640. If I didn't make any calculation mistake, let me just check again. Uh, I think so, yeah. So this is 1640. Okay, let's move on to question number 22. I'll say that question number 22 is the first question in this worksheet, which is significantly harder than the rest of the questions in this worksheet, although it's not as difficult as 24 and 25. So let's take a look at this question number 22. In the diagram below, we have AOB is a diameter, P and Q are points on a semicircle such that PQ equals to PB. When I saw this question at first, I decided to pause at this particular condition because I realized that, hey, wait a minute, that is a pretty unusual condition. If if PQ equals to PB, then if I draw the second radius, then actually this being the same tells you that we have two congruent isosceles triangles, right? Okay, so I took a mental note of this at this point, and I continue on. The extensions of AB and QP meet at point C. BC equals to 40, and then this ratio will be equals to 3 to 5. Find the area of triangle AOQ. Well, AOQ suggests for us to draw AQ, and at this point I noticed something that come out from the fact that I noticed the two congruent triangles previously. I noticed that we have actually a pair of parallel lines. We have a pair of parallel lines because if I call the angle in the middle as x, this is x here, then this is 2x. So what's both of these angles then? Then they will both be x. So we have our pair of parallel lines, which is AQ and OP, right? These two are parallel. In other words, the ratio here is also going to be 3 to 5. And in that case, if 40 is 2 units, it's easy to see that this must be 60 and this must be 60 as well. So very nice. We found the radius of the circle, right, from this condition. Next, we are required to use find the area of the triangle AOQ. How can we do that? One thing I notice here is that maybe finding this length on the other side will help us. So this is where we use the idea of what's the thing called again? Power of a point. Yeah, that's what it's called. So power of a point says that CB times CA equals to CP times CQ. Now, CB times CA will be equals to what? That's equals to 40 times 160, right? CP times CQ, we can use the fact that it's 5 to 3, we can, 5 to 8, we can do 5 units times 8 units. So then 160 is equals to 1 unit squared. So then 1 unit is equals to square root of 160. That's 4 times of square root 10. Okay, so therefore I can go and label each of the sides on the right side here. This is 5 units, so it's actually 20 times square root of 10. This thing here will be equals to 12 times the square root of 10. Now at this moment, it doesn't really help us to determine the area of triangle AOQ, but we also know something else. We know that PB is 12 times the square root of 10. So what we can do is that, yes, we can use it to find the area of this. And after we find the area of this, are we done? We can be done because from this area and from the fact that we have 3 to 5 and this being a 6 to 2 at the bottom, you can know the area of the entire triangle. And once you know the area of the entire triangle, you know the area of AOQ. So that will be the rough idea. Okay, so let's find the area of this BPC. Here we can use Heron's formula. So if the three sides are 12 square root 10, 20 square root 10, and 40, then the semi-perimeter is going to be their sum divided by 2. That's equals to 16 square root 10 plus 20. Okay, actually before that, let me do something first. Let me, instead of working with these three numbers, let's work with smaller numbers. Let's work with square root 10, no, uh, 3 square root 10, 5 square root 10, and 10, right? I have divided by 4 here to make it easier for us. Now, at the end, I must remember to multiply by 16 for the area, but that's not too important at this step. So S is equals to 4 square root 10 plus 5. So then, your value of square root of S times S minus A times S minus B times S minus C is equals to, let me write it here, 4 square root 10 plus 5 times, if I take away the side of 10 is 4 square root 10 minus 5, then 4 square root 10 plus 5 minus 3 square root 10 is 5 plus square root 10, then the other one is 5 minus square root 10. Okay, so the area of this is equals to, if you square 4 square root 10, you can get the value of 160, minus 5 squared is minus 25, then 5 plus square root 10, 5 minus square root 10 will be equals to 25 minus 10. Okay, so here this is 9 times 15 times 15, so the square root of this is equals to just 3 times 15, right? Which is 45. Okay, so we get that if I reduce each of the sides by 4 times, then using this as the side length, the area of the triangle is 45. So then the original area of this without reduction should be 16 times of 45. That's going to be equals to 720. Okay, now we are almost done. Okay, it's very long, but we're almost done. So now let me sketch a new diagram so that I don't have to look at the old one. Uh, Wait, I just realized my diagram is not very good, but it's okay. As long as it serves its purpose, it's fine. So here, after I get this part as area of 720, I can go and find the entire triangle's area. The entire big triangle's area will be equals to 8 over 5 times 8 over 2 times 720. Because this one here is 8 over 5. Right? Because this one here is going to be 8 over 2. And then after I get the entire thing, what I need to do? I need to multiply by 3 over 8 to get to this triangle here. So I multiply that by 3 over 8, and this will be my answer for the question. Okay, let me see if I can calculate it out. So cancel out the 8. Then this is what? 24 times 72. Right? That's equals to 576 times 3. That's equals to what? 1728, I think. Wait. Oh yeah, this is 12 cube. Yeah, this is 12 cube. Yeah, correct. Okay, so that's the final answer we have for this question. Now, let's move on to question number 23. For those of you who are in my Sec 2 class, we have done something like this just, again, maybe like 5 or 6 weeks ago, except that it was 2012, right, or some other number instead of 1183. Anyway, so this thing tells you that, okay, I can factorize 1183 into 5 different numbers. So let's try to do that first. You notice that it's not divisible by 2, 3, or 5. If you try for 7, you realize it's divisible. It is 7 times 100 and this is left over 483. That's 169. Right? Wait, no, that doesn't feel right. 7 times, yeah, 7 times 169 is correct. Yep. So this is 7 times 13 squared. But now 7 times 13 squared, you only have 3 numbers here. Where are your 5 numbers? Well, that's where the question comes in with the fact that they can actually be negative. If you choose to have negative numbers here, then you can do 1, minus 1, 7, minus 13, and 13. And this will give you 7 times 13 squared. So therefore, if you add up all of them together, you can realize that the sum is 5b minus a1 minus a2 minus a3 minus a4 minus a5. This is equals to the sum of 1, minus 1, 7, minus 13, and 13, which is just 7. So 5b is equals to 30, and then b is equals to 6. Okay, so that's question number 23. Now, on to the hardest questions of this particular worksheet, or rather this particular round one, which are 24 and 25. When I was preparing for this stream, I was almost entirely spending my time on these two questions. So that's why. Question number 24. This question here is not really doable by your usual counting ideas, because the phrasing of the thing is very different. You want your gap to be at least two numbers of difference. And this is true for all 5 digits. Now, the way we will do this thing is that we will do a recursion table. So how we do this recursion table? We can ask, how many of these will satisfy the first digit being 0, 1, 2, 3, 4, 5, oh, no space, wait, 5, 6, 7, 8, 9, where there are the number of digits being 1, 2, 3, 4, and 5. Okay, you might be a bit confused at what I'm trying to do here, but just let me finish drawing here and then you understand. Huh? So the way we are doing this question is we are doing it like how a computer would do recursion, by storing all the values here within a table, and then it spits out the values of tables to help my next step in my calculation. Okay. So if the question is saying instead, we're asking for a one-digit number, one-digit whole number, then how many ways are there? Well, if it's a one-digit whole number, it's easy, right? Every single one-digit whole number will work because the second condition is just useless. The fact that the gap between the digits is at least 2. Now, what we're going to do is that we're going to take a look at the next case where we take a look at two-digit numbers. Now, we know that two-digit numbers cannot start with 0, but let's pretend for now that two-digit numbers can start with 0. Then how many choices are there from the back? Well, that could be the case of the one digit being 2, 3, 4, 5, 6, 7, 8, and 9, right? So I'm going to add up everything from 2 to 9. There are 8 possibilities here. So this is 8. So let me just draw it out. 0 is from 2 to 9. And then what about 1? This will only be from 3 to 9 if you want a gap of 2. So there will only be 7 possibilities here if you start with the digit 1 for two-digit number. For a two-digit number that starts with digit 2, you're allowed to choose 0, right? Because the gap is how to explain this? The gap is 2 already, right? Then 4 to 9. So how many numbers are there in this case? 7 again, actually, right? For 3 something here, this can be 0, 1, or 5 to 9. Again, 7 digits. For 4 something here, this is basically at the middle case already. You have 0, 1, 2, and then from 6 to 9. Again, you have 7 cases. So it's 8, 7, 7, 7, 7. So by symmetry, the other cases will be 7, 7, 7, 7, 8. So we're done for 2 digits. Then what we're going to do now is that for the next case, for a 3-digit number starting with 0, we're going to sum everything from 2 to 9. We're going to sum up everything here together. How much is that? That's basically 8 times 7 plus 1. Right? 8 times 7 plus 1 is equals to 57. So this number will be equals to 57 here. And then for the case of 1, you only sum up everything from 3 to 9. What's that going to be? It's basically going to be 50, right? Because it's 6 times 7 plus 8. For 2, it's a bit different. It's 4 to 9 inclusive of 0. So this is actually going to be 51. Right. For 3, it will be 0, 1, and 5 to 9. If you add up all those cases together, it will be 51 as well. Right. And then for 4, it will be 51 as well. So that's by symmetry, 51, 51, 51, 50, and 57. Okay. Then we can move on to the four-digit cases. So four-digit cases, 0 will be the sum of everything from, again, the same thing, 2 to 9. What's that going to be? That's 51 times 8 plus 5. Is it? 51 times 8 plus 5. Yeah, 51 times 8 plus 5. That's 408 plus 5. That's equals to 413 for the case for 0. Okay. And then now, what about the rest of them? For 1, you ignore the case of 0. So it's 413 minus away 57. That's equals to 356. And then for the case for 2, you add back 0. You ignore the case for 3. Right. So there's a plus 6 overall. So it's 362. Yeah. 362 and then 362 and then 362 and then by the symmetry, the other cases are all 362 as well. Then this will be 356. Okay, hopefully I didn't make a mistake in my calculation. If any of you have the final answer in the messages, you can also tell me, just in case I make a mistake here. And then the final step, the number of 5-digit numbers starting with 0, we actually don't need it because we're already at a 5-digit case, but we need it for 9 anyway, so let's just go and calculate out. That one here will be equals to 2 to 9 is you have 6 copies of 362, and then you have 1 copy of 356 and 1 copy of 413. So I'm just going to skip ahead in the calculation here. On my paper, I wrote down what this is supposed to be. This paper is this is going to be 2941. Okay, so there's 2941 of them starting with 0. Now we don't care, we only care about all those starting with 9, right? For 1 here, we are adding those from 3 to 9. So we're just removing the case from 2, which is, if you remove that case is, wait, sorry. For 1, you are removing the case of, okay, I already realized I made a mistake here already. Let me just see for a moment. I think I made a mistake in my previous case. So let me slow down and rewind my previous case one more time. Okay, my previous case was the number for 0 is the sum from everything from 2 to 9. I determined that to be 413, which was correct. Then I removed the number from 2, in my case for 1 to 9. So I removed by 51, not by 57. So this is actually 362. This is 362. I made a mistake here. And then for the next case here, where we have the digit 2, we take from 0 and 4 to 9. So that's going to be removing a 51, adding back a 57. So this is 368. Yeah, in fact, these are all 368. Okay. Let me just see. No, sorry. For 2 is 368, but for 3 is again different number because the number for 3 adds up from 0 to 1 and then adds up the case from 5 to 9. So that number is going to be, let me write it down. So 57 plus 50. And then you have 5 to 9 here, which is 51, 51, 51, 50, and 57. Okay, this number is a little bit weird now. This is 370, no, 360, 367? Is that correct? Wait, let me just see. Oh yeah, 367. Yeah, very 367. Okay, so this is 367. This is 367. This is 367. This is 367. This is 368. Then this is 362. Okay. So finally, my number here, this is not 2941. Okay, I'm just going to press my calculator here because I just want to finish going through this question. What is the number here? Let me calculate it out. There will be 2 to 9. So it's 368 plus 367 times 4. Okay, it's 2 times 368 plus 362 plus 413. That's 2979. Okay. For uh, the case of 1, you're adding up everything from 3 to 9. So everything except the one for 2. So it's basically 2979 minus away 368. That's 2611. And then for the case of 2, you're adding back the case for 0. You're removing the case for 3. So adding back this thing, you're removing this guy. So you're adding back 413 by removing 368. That's 2656. And then for the case of the next number here, we have our number at 3, which is you add the one at 1, remove the one at 4. So you add 362, you remove 367. That's going to be minus 5, right? So it's 2651. And then the next one here is when you add the number at, for the case of 4, is you add the number at 2, remove the number at 5. So you add 1 here, so it's 2652. Yeah. Okay. So with that, we can basically have a final answer already. So this is what it looks like. So therefore, the final number of 5-digit numbers is going to be 2 times of 2611 plus 2656 plus 2651 plus 2652, then plus another 2979. Yuck. This is so disgusting. Okay, so let me try to calculate that. This 2611, 2656, 2651, 2652, then times 2 plus 2979 will give you this number, 24119. And that's the final answer here. I'm not sure if there exists a better method for this question. At least this was the one that came out to me at first, and then it felt doable. Although actually, in fact, if you take a look at the calculations are probably way too long to be spent for this SMO junior section, right? Now, there's another idea I could think of for this question, but it will take probably equal amount of time to calculate, which is something like principle of inclusion-exclusion. You can take a look at the number of cases where the two digits next to each other are difference of 0 or 1. Then you can look at each of the possible pairs and then go and do principal inclusion, exclusion, all the possible cases. But that will be equally as long, if not more complicated than this. So yeah. Okay, anyway. Question number 25. Question number 25 here. Unfortunately, for my current students, you all will not be able to do this question because the topic of Mendelaw's theorem is only taught to you all on semester 2 of secondary 2. So what does Mendelaw's theorem say? It says this thing. It says that if you have a triangle and then you draw a transversal through it, cutting the triangle at 3 different points, one here, one here, and one here, then you can have some kind of ratio. You can have the ratio of ax over xb times bz over zc times cy over ya equals to 1. This is Mendelaw's theorem. Now, it seems to be useful for this question, but the question becomes, how do I use it here? You notice that the question says that CD is the median of the triangle ABC, but it never specifies anything about G. G is just some random point on the median, right? So what we can do is that we can shift G to anywhere and the answer should still be the same. In fact, what I'm going to do is that I'm going to shift the line EGF to this position where it is parallel and passes through the point D instead. Now, this will be better because of the fact that, firstly, you don't change any of these values. You change them, but you change them all equally. Because of the fact that it's parallel, each of these denominators is multiplied by some factor. And because it's multiplied by the same factor, we can see that the k value will not change, right? Okay, and this is better because it passes through point D, and we can try to use the fact that AD equals to DB now that it's here. So let me call these 2 points X and Y. Our new condition becomes Cx over, sorry, Ca over Cx plus Cb becomes still Cb, Cf becomes Cy, and I've moved point G to point D, so it's just K on the right hand side. Okay? So suddenly our problem looks to be a lot easier. But still, it requires probably some work. Ca over Cx plus Cb over Cy. Now, some of you probably already can guess from the answer that it should be equals to 2, right? Where because Ca over Cx looks like it's equals to 1, Cb over Cy looks like it's equals to 1. In fact, in the case where the triangle is isosceles, it's exactly going to be 1 over 1 plus 1 over 1. So you already know the answer K is supposed to be equals to 2. But how to show it using this Menelau's theorem? Now, one thing I realized is that uh, both of them are very close to 1. So what I'll do is I'll subtract 1 from both of them. So what if I did Ca over Cx minus 1 and then Cb over Cx over Cx plus By over Cy, right? This is equals to K minus 2. And actually, this will be 0. The reason why this is 0 is because of Menelau's theorem. If you apply Menelau's theorem, treating this thing here as a line and treating your triangle as your xyz, then you can jump from C to A to X. Sorry, that's the wrong way of using it. No, sorry. You want to treat the triangle as ABC and the transversal as x dy. So you want to jump from C to X to A to D to B, and then B to Y to C. This is equals to 1 by Menelaus. Okay, and if this is equals to 1 by Menelaus, then what we can see is that AD over DB firstly is equals to 1, right? So we can remove this guy. Then we can get that CX over XA times BY over YC is equals to 1. In other words, AX over CX is equals to BY over YC. So from here, if you go back and substitute inside here, you'll notice that this is equals to 0. So therefore, K equals to 2. And so 12K equals to 24. So this is the answer for this last question. Okay, I'll stay here for maybe 10 more minutes until 6 p.m. See if any of you have any other questions for this year's SMO round 1. By the way, is there anyone who actually also calculated question 24? Because um, I'm afraid I made a calculation mistake somewhere, which is very possible with a calculation of this size. So I'm curious if anyone else were able to do it or something. Okay, if nothing else, then I'll stop this right now.